Hi, hello. Welcome to Learnwizz. It's me, Learnwizz. In this session, we are going to discuss a small topic from the chapter Extraction of Metals from SiO₂ Chemistry. So, our topic is extraction of iron. It's a very important and simple topic. Okay, let us have a look. Extraction of iron. So actually what is this extraction of iron means? That is, we know that in the earth crust these elements like iron, aluminum, etc. will be in the combined form with air, yeah, other it will be in different forms of compounds, right? So in the earth crust, we know that the metals like iron, aluminum, etc. will be in a combined form with some oxygen, right? So we have to extract the metal alone. Okay, that is extraction. So these metals will be in the form of the ores. Okay, we are extracting ores. Okay, we are extracting the ore. So iron exists in many different ores like hematite, magnetite, iron pyrites. We call it as fool's gold, right? So in the extraction process of iron, we are taking hematite ore. Okay, hematite. In the extraction process of iron, we are taking its ore, hematite. Okay. What is the formula of hematite? That is also very important. Fe₂O₃. That is the formula of hematite. Okay, let us have a look. Now we know that during the complete extraction process, there are mainly three steps. And the first step is concentration. And what is this concentration of the metal means? Concentration of the ores, we call it as. Concentration of the ore means concentration in this process, we are removing all the impurities, okay, from the ore. Like we can do so many process. In this case of extraction of iron, we can do two process. Like first one is hydraulic washing. Just what is the hydraulic washing means? We have to wash it with water so that lighter impurities will go off. Okay, so we get the pure ore. Then next method you can employ is magnetic separation, because we know iron, right? Iron is having some magnetic property, right? It's a magnetic property. Then we know that iron is having some magnetic property, right? So we can do what? Magnetic separation. Okay. Also, these two processes are used for the concentration of the ore, and the hydraulic washing process is also called as levigation. Another name, okay, hydraulic washing. It's also called as what? Levigation. So this is the first step. And the second step is extraction method. Extraction. So in this extraction method, either we have to do calcination or roasting. In this process of extraction of iron, we are doing roasting. Okay, after roasting, this iron ore will be converted to its oxide, Fe₂O₃. Okay. Then the third process is refining of metals. Okay, refining. Refining means, so after all, we get the during the extraction process we get the oxide of iron, right? And we have to do, in the second step of that, we have to do some reduction process, so that this oxygen will remove from that metal and we get the pure metal. But since that pure metal still have some impurities, right? We have to refine it in the third process. That is the three steps of extraction. Okay, so first step concentration, second step extraction, and third step refining. And the concentration, there are two methods: hydraulic washing and magnetic separation we can employ. And the second one is extraction. Here we are doing roasting process, okay, and we get the ore in the form of its oxide. Okay, after that we are doing the next step, or next we are doing is that in a very big furnace. Okay, I will show you the furnace. It is called as blast furnace. a blast. Okay, it's like a blast of air, hot air. We are you can see here from the from the bottom of that blast furnace, hot blast air we are passing from the bottom of that, right, blast furnace. That is why it is called as blast furnace. Okay, so too much hot in the bottom, and when we move up, uh, the temperature reduces. You can see here, right? Then what is happening is that we are adding here three things. Okay, there are three important ingredients we are adding to this blast furnace. That is from the top. Okay, not from the bottom. Only hot air is passed from the bottom, and from the top we are adding three main things. Okay, what are the three main things? First one is, yeah, of course, our ore, iron ore. Okay, iron ore. That is here we are doing which ore? Fe₂O₃, hematite. And the second one is coke. What is coke? Yes, it is carbon itself. And the third one is limestone. Okay, limestone we are adding. And what is limestone? It is calcium carbonate. So these are the main ingredients, or these are the only ingredients we are adding to this blast furnace. Okay, and along with the air from the bottom. Okay, and one more thing you have to remember here. After roasting, okay, after roasting means we are heating, right, in the presence of air, right? So after roasting, most of the impurities will move up as the gases. Okay, but there is one impurity in this hematite which is not gone. Which is that impurity? It is SiO₂. Okay, that is silicon dioxide. So what is our task? This impurity is so much like this iron. Okay, so it won't go like that. So we have to remove that impurity. That is our task. Okay, so what you have to do? Yes, we have added iron ore. The impurities will be also there in the ore. Okay, that you have to remember. Okay, then what is going to happen in this blast furnace? That is we are going to discuss. Actually, there are 5 steps here. Okay, so we have added first coke, right? So remember we have added coke, coke is carbon, and we have added hot air blast. What is air? Yeah, it's of course oxygen, right? Yes. So this carbon, that is coke, will react with this oxygen, forming what? Carbon dioxide. In the first, this is the first step. C plus O2 gives CO2. Okay. Again, what will happen? Carbon dioxide, okay, will react to oxygen. Again, oxygen is there, right? And carbon dioxide has formed. This will react to the oxygen, forming what? Carbon monoxide. Okay, we need this. That is why. Okay, why we need this? That is the next thing. Next step you will understand. The next step, this Fe₂O₃, okay, that is a ore, will react with the carbon monoxide. And this carbon monoxide acts as a reducing agent. What is that reducing agent means? Yes, we want iron, right? This Fe, right? Because we want it. Because we have to remove that oxygen. So what is this reducing agent will do? It will abstract that oxygen from the iron. Okay. So you will get iron. Okay. So what will this what will this CO do? CO is acting as a reducing agent. That is, it acts as what? It abstracts. It abstracts the iron. Sorry. What does this carbon monoxide act as a reducing agent, right? So what does it do? It will abstract oxygen from Fe₂O₃. Okay, so that we get what? We get iron back. Okay, along with carbon dioxide. So here there is 2 Fe, so I have put a 2 here, and you have to balance this, right? So how many oxygen atoms are there? Like that you have to balance. Okay. So what happens here is carbon monoxide act as a reducing agent. Very important. Okay, who is acting as a reducing agent? Okay, and what is the function of this coke? What is the function of this coke? Yeah, its function is to prepare this carbon monoxide ready so that it can abstract oxygen from Fe₂O₃, and we will get iron. Okay, we will get iron. Okay, now we have to balance this. We have to yeah, here you can see here in this blast furnace, first step is carbon reacts with oxygen forming carbon dioxide. Okay, and this carbon dioxide again reacts with the carbon giving carbon monoxide. Next step is carbon monoxide reacts with Fe₂O₃ forming iron. Okay, so for next step, next you have to balance this. Okay, 3CO and 3CO2. So the equation is now balanced. In the fourth step, so only we have taken coke, then here we have taken the ore. Okay, hematite. Then what is remaining? One more thing. So we have got iron, right? Then what is the purpose of limestone? It was our task to make this iron, right? It is already there. But we know that there is one impurity still in the hematite, right? Which is that impurity? Yes, it is silicon dioxide, SiO₂. We have to remove that. That is our task. So for that purpose, we have added calcium carbonate. So calcium carbonate, when it moves down, it becomes, they're very much hot, right? Okay, calcium carbonate, when it moves down, it becomes very hot. So it will undergo thermal decomposition. Okay, and decomposition, it will form calcium oxide and carbon dioxide. Okay, and for this is what we want. For what we have added this calcium carbonate. This is what, this is the flux here. This flux will react with our silicon dioxide. Yeah, that is the gangue, right? It was the gangue. This flux will react to the gangue forming CaSiO₃. What is this? This is called as slag. Okay, and it is called as calcium silicate. Calcium silicate. So question will be asked, what is the purpose of this calcium carbonate? So we have to say that calcium carbonate is used to prepare our flux that is needed to remove the gangue from the impurity. So this is the slag. Okay, calcium silicate. Calcium silicate is our slag. Okay, flux plus gangue is slag. Now we have to study. So we got the iron and slag is removed. So this is the iron piece we get. Okay, okay, here you can see that slag. Okay, we can remove it. Okay, we can remove it very easily, and you get the iron. And here also, after getting this iron, it is still having 4% of carbon. Okay, still having some impurity like 4% carbon. We call it as pig iron. Pig iron. So after the whole extraction process in the blast furnace, still the iron we get have some impurity, that is about 4% carbon. We call that iron as pig iron. Okay, so this is the whole process of extraction of iron. And 1, 2, and 3, 4, 5. 5 steps. You have to study these steps in this order itself. Okay, because first of all you have to make this carbon monoxide. That is your task. Then only you can remove the impurities. Then only you can remove the oxygen from the iron, because carbon monoxide acts as the reducing agent, right? Then only at a particular temperature, coming bottom, only this calcium carbonate can decompose, because it needs heat to decompose, right? Moving up, there is little bit temperature only. Coming down the blast furnace, temperature is more. So calcium carbonate break down, undergo thermal decomposition, forming calcium oxide and carbon dioxide. Okay, And what is the purpose of this calcium carbonate? To make the flux. Which is the flux used in the extraction of iron? Yes, calcium oxide. And which is the gangue present in that? Yes, SiO₂, silicon dioxide. And which is the slag formed? Calcium silicate. Okay, so these are the 5 steps of extraction of iron. Hope you enjoyed the video. Okay, if you want more notes, more videos, please like, share and subscribe our channel. Okay, see you in the next video. Bye. Thank you. Have a nice time.